Today we're continuing with React, week 4, day 2. Come on. All right, let's have a review. Before, in weeks 1 through 2 and 3, we had HTML and we used JavaScript to put more HTML in. But now that we're in React, that's not how that's going to happen. We have very little HTML, guys, and our JavaScript will conditionally put HTML in based on the state of our application. Okay? Why do we want to do this, guys? Come on, does anyone say anything? Why do we want to conditionally put HTML in based on JavaScript logic? What are some things that we talked about? It's faster, it's easier to manage, right? It follows the same patterns that we end up having anyway. Some of the same patterns, a little bit of HTML with a little bit of JavaScript. So it solves some of the problems for us of how to conditionally render our page. And that's why in the future, you guys are going to start seeing a lot of functions called render. Okay, render. Render just means draw something on the screen. We're going to name certain functions: render navigation bar, render tweet list, render to-do lists. Okay? Some of the 4 main concepts, once again, are components, JSX, props, and render. Components can do what, guys? Our components can have children. Our components can have props. Our components can maintain their own sense of state. Okay? And there's always gonna be one really important component in your guys' applications called the app component. It might be called something different if you guys run npx create React app and then a different name, but it's probably gonna be called app. JSX. JSX is basically like HTML, except it's a little bit different, guys, right? Some of us had some mistakes yesterday. We wrote strings where there should have been curly braces, right? The syntax is a little different, but I'm confident that everyone, after walking around class yesterday and looking at everyone's assignments, you guys are doing okay. And props. Props is an object. That's what its data type is. Our components will receive this object. They will receive a props object, and it's up to us to determine which props they receive. Depending on what the component does, it may need to have additional props. You know, it just depends, guys. And in a second, we're gonna see how this works. And once again, render. Render means just draw something to the UI. Okay, so we're gonna talk about functions, props, and state some more. This one's kind of dumb. Why do we call it React, guys? Exactly. It reacts to the state of our application. You sound amazing, man. Thank you. That's exactly what the slide says, because it reacts to things. Our UI will simply react to our application state. Okay, so this one is going to be called, like, once you guys get better and start imagining, like, the analogy I always use is like your data is like electricity, right? Just like this building. This building can have multiple places to get electricity. You can have a generator, you can have a solar panel, right? You can have a cable that's from the street, and this street, and that cable connects to a power plant that burns coal or something like that. There are many different places our application can get data. Some of it is from the user, some of it is from us, some of it is from an API. But the most important thing to think about with React is that despite the fact that our data comes from multiple places, their behavior isn't really connected, right? So for some of you guys who were able to count the number of tweets, right? What was really going on, right, is that we had to write a function, okay? We wrote a function. When that function executed, we ran some code, right? We ran some code to determine how many tweets that this tweet had, how many retweets that this tweet had, and then we counted it, and then we told our UI, please put this to the screen. So our code is responding to some behavior, responding to the tweet button. And the differences between these two are called imperative and declarative programming. So imperative programming isn't good. We had to tell our tweet button what to do. We had to say, hey, when the user clicks this, go look at this data, sort the data a little bit, perform some validations, and then take that number and stick it in some UI. Imperative programming is very difficult to maintain. I know this seems like an abstract word right now, but we'll get a feel for it later. Declarative is a little bit different. We just tell the computer like what we want to have happen, and the computer will figure out how to do it. If you guys look at the slide, you'll see a more in-depth guide right here. Okay, it's metaphor time, guys. Declarative, being declarative is like saying, hey, I want you to be romantic. Whereas imperative is saying, go to the store, buy me flowers, buy me wine, take me out to dinner, take me to a park, have a nice chat with me. I don't think girlfriends would want that, for them to have to constantly tell you, go buy me this, take me eat here, blah, blah, blah. But they do. But what I'm trying to say is, I think the better way would be for a girl to say, you know, I want you to be more romantic. And then for us to figure it out, you know, like what does that mean? You know, and allow us to decide how that results. So for example, we define a final state, our application state. So let's just say if romance is true, we'll draw something red, right? We'll say something is red. For example, remember how we changed text yesterday, guys? And we change text sometimes. We change the prompts. We can change a lot of things, okay? But we want to imperatively program. We want to tell our application, like, hey, there's a bunch of different ways that this application could have the state set. You know, the state could look like a bunch of different things, you know? But in this situation, look like this. You know, if I want you to, if the state is like this, I want you to do that. If the state is like that, I want you to do this. But we don't want to have to constantly say, hey, go find this div, change that div. Because that becomes very difficult later on. So instead of click button, we're going to move to increment heartbeat and set button color. Once again, reacts to state automatically. What will happen, guys, after we set state? What's going to happen to our component? When we do this, that set state, what happens?
Update this state or
Yeah, it will update the this, that state object, right? But something I want you guys to always remember is that when we update state, our component will render again. So it will always reflect the newest state that we have in our application. There's a lot more magic going on. It's a bunch of magic, actually. Some of you, I saw why you're looking at some of how React is actually written, right? The actual components that it gets parsed to. It's impossible to read. No one can read that. So just know that the reason why we want to do this, have it render again, is that this is actually the most performant way to do an application like this. Despite the fact that we rendered the UI again, this is the best way to do it. Every single time the state changes, render it again. And don't change what you have. Just throw everything away, start over with the new data. And that helps us out a lot. So usually, we're going to respond to two things. We're going to respond to like a click or a form. A form could be anything. It could be an email and a password. It could be a city. It could be a select box. It could be a checkbox. There are many forms on the internet. You know, if you guys go to tiki.vn and you guys want to order something, we're going to go through a bunch of forms, right? We got to put in our address. We got to select how many of this color shirt do we want? You know, what size do we want? Those are all called forms. Any place where a user enters data for us is considered a form, where they enter their age, etc. And so other than a user action like a click or a button, the most likely thing that will trigger our state change will be an API response. So when the page first loads, we kick off an API response, just like our news app, right? When the page first loads, we kick off an API request, and when that data comes back, we say, okay, I got this data back from the API, we need to update our state. And then when we update our state, our application should behave how we expect. Okay, that's it. So we talked a lot about state, and I know that like this is all very abstract. So I'm going to show you guys an example. Okay, it's a very contrived example. Who here knows how to play paper, rock, scissors?
Wait, what? Rock, paper, scissors.
Paper, rock, scissors.
No.
Everyone, you can say that anyway, man. Paper, rock, scissors.
Dude, what are you talking about?
Fine. Hey, look, paper.
Ball basketball with the ball and basket. What are you talking about? Rock, paper, scissors. Rock, paper, scissors.
Rock, scissors, paper.
Oh my goodness.
Rock, paper, scissors.
There it is.
Fine, we'll call it paper, rock, scissors. Who here knows how to play paper, rock, scissors? Who here? Come on, guys. I need some help. All right, I'm going to need you guys to help me build a game where we're going to play paper, rock, scissors, okay? I'm going to show you what we're going to build. What's it called? Rock, paper, scissors? Is that what it was? Okay, so right here we can see that when the UI first loads, we see an image. And then we can select paper, rock, or scissors. Also on the left, we have a history of how many games that we've played. So let's go ahead and select one. And I can see that I selected paper right here. Got a paper. My prompt said, hey, this is paper. And it also told me I won last game. Yeah, I won last game. Evidently the computer chose something else. But I won the game. It's in our history, okay? So let's go ahead and confirm that this works correctly. Oops. Okay, so I'm going to do something. I'm going to console log state when the render loads, when our render loads, okay? And we're going to prove that this works, okay? Okay, so the application rendered, I randomly chose paper, rock, scissors for the computer, okay? You guys don't even need to see the code right now. Just understand the logic, okay? We randomly chose a computer's choice. The computer chose paper, okay? Who here sees where I'm pointing? Raise your hand. The computer chose paper. Okay? What is this inside of, guys? What does that look like? What data type is that? It's an object. We render it here, or we console log here on line 131. What is this object? Where's this object coming from, guys? Where's this object coming from? What am I console logging? State. State is an object. I'm going to prove this to you. Type of this.state. Refresh it. And when we see that our state is an object. Okay, does everyone get that? All right, we're moving on. So anyway, we see that the first time the application loads, the second ago was paper, now it's rock. Okay, it's rock again. Now it's paper. Computer choice is paper. So if I choose paper, what should happen, guys? The computer randomly picks paper. If I chose paper here on the left, it's a tie, right? Okay, so if the computer chooses paper and I choose scissors, who wins? Okay, let's prove this. We hit scissors. Okay, so it seems that when the computer chose paper and I chose scissors, the player won. It shows that I did correctly choose paper or scissors up here. The text said the correct thing. My choice was scissors. And it said I won the game. Because remember, the computer chose paper, I chose scissors. Right? Okay, let's do one more. Let's go ahead and look at our state object again. And we can see that in our state object, we have the computer's newest choice, scissors. And we have my last choice, scissors. We also have our game history. I created the object pretty simply. It has 3 keys. We have a result, we have a computer choice, we have a player choice. So it seems correct. The player chose scissors, the computer chose paper, and the result was player 1. Okay? So So everything seems okay. The paper chose scissors, the computer chose scissors again. So now the computer chooses scissors. I'm going to choose paper, and I expect over here on the left it says computer 1. So let's think about this. Let's look at our game history again. Let's look at game history over here. So a second ago, the computer chose scissors. We chose paper, and the result was that the computer won. Okay? All right, that's what we're about to build, ladies and gentlemen. Okay, we're gonna do our good old-fashioned create React app command. We'll call this npx create React app. What is it? Rock, paper, scissors? Rock, paper, scissors. It's gonna take a second. So you guys see that I'm moving into the project, right? This is on my desktop. I have CoderSchool. I have Yosemite. I now have a new folder called rock, paper, scissors. Okay. I opened up the code editor. Let's look at app.js. Okay. Let's go ahead and delete everything in here just to confirm that it looks good or that everything works fine. I need to stop the previous server, and then we're gonna run our React application by navigating to our project that we're creating, and then we're running npm start. Okay, so we see hello here at the top. This is a brand new application. It's a new folder. All right. Now let's think about this. I'm gonna copy over the choices because I want to save some time. Let me close this real quick. So we got choices. We need to actually do a little bit of update here because we want this our app component to be not a functional component, a container component. And just know that a container component holds a lot of state and it passes its state to other components. Okay, this is the biggest, most important component that we have. So we'll say class app extends react.component. And we'll check to make sure everything, okay, after we do that, we need to refactor. We need to create our render component, our render function, and then move the return up here, right? Because the default one that we got is called a functional component. A functional component does not have awareness of state. We need a component that has awareness of state. What's class component? We gotta spell component right. Okay, so everything looks okay. So now we're gonna say, what do we want to see, guys? Buttons? Well, actually, let me show you one additional thing, okay? Unlike the projects that we've done before, now we're gonna start using a package manager so that we can get Bootstrap. So we'll look up at React Bootstrap. We'll say get started, and we can see that this is the command we need to run. Okay, we're gonna go out to the internet, get some files, and add it to our computer. This is different than what we've been doing with the other index.htmls. Okay, now we're copying files to our computer. So I run that command, npm install react bootstrap, and now we're introducing a new concept. We're introducing the concept of importing components from libraries. Okay, so you guys can copy this line right here or this one right here. I prefer the second one. The difference between this line right here up top and the line below is how they're exported. How they're exported from their individual files. Okay? And until we start exporting, I don't want to get into this yet because this can get a little bit tricky, right? So depending on, just like right here, do you see how we have export default? There's a different way to export a component. This also works. Okay, so imagine, so if line 21 is how we exported the app component, we could import it using this syntax from app, right? But if we export it this way, we have to import it. If we have a structured export, we also have to have a structured import. These two go together. These two go together. Okay. I know it's a little bit confusing. I know it's a little bit confusing, guys. But just go with the one that they say out in the bottom. Okay, we're gonna replace this. We refresh. Okay, we installed the library by stopping the server and running npm start. Now we got to run npm start again because we had to stop the server, install the library. Now we have to restart the server again. Okay, so we see our hello, and the server doesn't seem to be complaining. So let's go ahead and use this button. Okay, let me explain one more concept. The reason why I'm importing a component to be used is because it already has a lot of magic for me. Okay, I don't want to do a lot of stuff. I don't want to style it myself. Just like with Bootstrap on the web, this is Bootstrap on React on the web. So now we can just look at examples of what they have already. Okay, look at components. And then we'll just say, let's look at some buttons. I see some buttons right here. I'm gonna copy this whole line. I'm gonna paste it here. Okay, and we can see that this component that they use right here, we didn't import it yet, guys. We didn't import this yet. So I'm gonna import this from Bootstrap. Oops. There we go. All right, so let's go ahead and refresh our page. Oops. I don't know how that got there. We have one more problem. There. Refresh. Thank you, thank you. Okay, so we got a bunch of buttons. But we don't need a bunch of random buttons, guys. What do we need? We need 3, exactly. So we call it rock, paper, scissors. Okay, so we now have 3 buttons. When we click on it, nothing happens. So we need to add an additional function to our component. We'll call this one on select on player choose. Okay. This is what, guys? What is this? What does it look like? What shape does it have? This is a function. Okay. So let's just confirm to make sure that we can get the function to fire. .log on player choose right here. This is going to take an argument. It's going to take choice. It has to have a choice. Okay. So now we need to add some behavior to our button. So let's go ahead and say on click. On click. We're going to fire this function. On player choice. This dot on player choose. And what is this one choice, guys? What is this one? Rock. Okay. So let's go ahead. Yes, this is the argument. I'm hard coding the argument right now, guys. This is, where's rock going to go whenever we click it? It's going to go to line 13, guys. It's going to become choice. Rock on line 21 is going to become choice on line 13. We're passing data. Data is moving through our application, okay? And we're going to console log it. So let's save, refresh. We click rock. We see that rock was passed, okay? So let's go ahead and make this smarter. Rock, paper, scissors. Paper. Spelled that wrong. Scissors. Scissors. Okay, so let's do rock, paper, scissors. Okay, so now we've successfully determined what the user has chosen. Okay, now let's go ahead and figure out a way to just look at our state every single time our application changes. Okay, so now we can say this dot set state. We're gonna say player choice is choice. Okay, so refresh. I expect whenever we push this button, guys, our function will be called. Our function inside of it runs line 15, which updates the state of our application, of our component. And then because the set state function call is fired, I expect line 19 to console log the state. And then we should see an object in our console log. And that object should have a key. Yes?
One more time. Say it one more time. This is a little fast one.
Okay, so when I click this button, when we click this button, rock, right? We expect on player choice, the function to fire, okay? When it fires, it will send the argument rock to line 13. Rock will be inside of choice. We're gonna see a console log on player choice, and we're gonna see the choice, okay? And then on line 15, we're gonna set a new state to our application. And then our application will simply react to our state. Our application will simply react to our state. So on line 19, when our state updates, line 19, the render function will fire again. Every single thing inside this in the render function will fire again with the new state. Thus, on line 19, we're going to see the newest state. Yes?
So the set player choice is the name you name it, right?
Yes. So the object will have a key called player choice. I'm going to update the player choice. Okay. The first time we look at that state, we're just going to see an empty object. The first time we see this, they're just going to have an empty object with no keys. After we click a button, we're going to see an object with one key. Okay. We're trying to represent our users' behavior in state. This is why I keep talking about state. I've talked about this for the last couple of weeks. The state of the application. Okay? So we click rock. The first time, state was null. My bad. I thought it was an empty object. It's actually null because we don't have anything on there. Okay? So the user clicked the button. We see that they clicked rock. And then we set state. The state is now player's choice is rock. Okay? You guys all with me? Okay, so. Okay, when a player chooses, guys, we gotta have some logic here, man. I don't know how to play paper, rock, scissors. Fuck. Shit. Rock, paper, scissors, yeah. Okay, guys, so it would seem reasonable that when we play rock, paper, scissors, I gotta have someone to play against, right? If I throw rock out and I don't have anyone to compare against, how do I win? How do I know if I lose? Right, guys? So, our complex components will need some type of initial state, okay? And now we're gonna introduce a new component, or a new function on our component called the constructor. Constructor. This is how we write it. Super props. A constructor can get no simpler than this. This is how it has to look, okay? It has to be called constructor. It has to have an argument called props. It has to call another keyword called super. This is like super advanced now. This is like for real. Like super is like super advanced design patterns with programming. Okay, you guys are getting into more advanced programming. Anyway, so you guys gotta make it look like this. Okay, but the constructor typically we do it to set up some initial state. That's what its purpose is. Okay, so I'm gonna say this dot state equals. And then we're going to say computer choice. Computer choice. And then now we need to randomly select from this array, guys. How can we randomly select from an array? Does anyone remember? Do you know every character? Can you tell me every character? I don't know what to type right now. I really don't. Okay, fine. I'll Google it. Random element from array. Okay, I don't remember, guys. Sorry. So, where is it at? Okay, here we go. So this looks good. We're going to go ahead and put this one up here. And we don't have items, guys. What do we have up here on line 6? We have choices. So we're going to do some magic here, some computer science. Computer. So we're going to say computer choice. Const. So now we can just shorthand this, guys. Instead of doing this right here, because the variable is named the exact same thing, we can just do that. Okay? So let's save it and refresh. Oops, wrong screen. Refresh. And we can see that the first time the application loaded, our computer did have a choice. Paper. You guys see that? Paper. Scissors. Paper. Scissors. Scissors. Paper. Come on, where's rock? Rock. Okay, we successfully got all three of them. Okay, so our initial state is a computer's choice. Our initial state, we've set up a computer's choice. What else are we going to need? Guys, let's think about some of the data that we worked with, right? What are some of the data types we worked with over the last 3 weeks, right? We had a to-do list, right? What else we have? We have a tweet list. So let's maybe have a game history. Does that make sense? How do we work with these lists in the past? We gave them arrays, right? We stuck stuff inside these arrays, and that's how we managed our data. So we're going to do that a little bit. We're going to do that some more. Okay, so we've confirmed that the user can select something. Okay? So now let's go ahead and on our player's choice, we're going to run some conditional logic. So the first thing I think would make sense is that if the player and the computer chose the same thing, we should automatically say that the result is a tie. So if computer choice, oh my bad, we got to get that state first. Okay, const computer choice equals this dot state. Guys, remember, we've done this so many times now. We've just destructured a key off of an object. Our state is an object. Remember, we console logged it on line 32. Our state is an object. We grabbed one key off of it. We want this one key. Okay, so we say if computer choice is the same thing as, let's name this better, player choice. If our computer choice and our player choice are the same, we're going to say that the result is a tie. Result is tie. Okay, now let's go ahead and declare the variable. Let result equals that right there. Okay. Okay, so if the computer choice and the player choice is a tie, if the computer and the player's choice are the same, it's a tie. So now let's confirm that this logic works correctly.
The result in line you have to set it equal to an empty string.
I don't know. There's certain. Oh, because we haven't used it yet. So there's different rules for ES linting, guys, right? It depends on how our application is configured. Facebook, when we download, when we use Create React App, it already has some configurations for us and how they want us to write code. Okay. So it's okay. It's the console log. Okay. So let's look at our state. When our application first loads, the computer chose rock. If I choose rock, I expect to see a console log. No. Let's think about this. I want you guys to constantly think about like stopping and thinking about what you expect to have happen. We want line 29 to execute, right? Because we're console logging result, right? So if the computer choice and the player choice is the same, it's going to be tie. Result should be tie. So we look at our computer's choice. We see rock. And if we choose rock, we want to see results say tie. So we choose rock. So we do have a tie. We can prove that line 29 actually executed. Line 29 did in fact execute. Excellent. Okay, so now we can get a little bit more complicated. We need to do a bunch of different checks, right, guys? Because what if the player chose scissors or rock? We gotta cover all these use cases. So if the player choice is equal to rock, what are we gonna do, guys? We already checked to see if the computer had the exact same choice as us. So now we just need to see if computer choice is equal to what is rock if it's not rock? Paper. Okay, paper. Okay, that's good. So we'll say what was the ones? I'm sorry, I'm cheating. It's a good name here. Okay, fine, let's get this. Result equals, so if the player chose rock, right, and the computer chose paper, what is the result?
You can't just use an
Player loss?
You can't use an N.
What do you mean an N?
Player choice equal rock and computer
Okay, exactly. That's a better way of doing this. I'm writing this really bad right now because it's easier to think about, and then we're going to refactor. Okay. So I want to talk about in terms of when. Okay. So I'm going to say. So I'm happy that you guys are thinking about better ways to do this. That makes me very happy. That's the truth. I want you guys to look at this code and write better code than me. Okay? So I'm going to copy this right here, and then we're going to say, if the player chose rock and the computer chose scissors, who won? If the player chose rock and the computer chose scissors.
The result for the first one, if the player chooses rock.
Oh, my bad. Computer won. Okay. See, this is a bit confusing, guys. It's easy to fuck this up. Rock, paper, scissors is really hard, man. Trust me. Okay, trust me. I'm not lying. So if the player chose rock and the computer chose scissors, the player won. Does that make sense? Okay, so now we can do this 2 more times. Oops. Okay, now so the player chose rock. Okay, what about the player chose paper? If the player chose paper and the computer chose scissors, who won? Okay, if the player chose paper and the computer chose rock, who won? Okay, our last. What do we have so far? We have rock, paper, scissors. Okay, scissors. Okay, so if the player chose scissors and the computer chose rock, the computer won. And if the player chose scissors and the computer chose paper, the player won. Okay, so yeah, I think this looks good, guys. So let's look at our result. Guys. So the computer chose rock. Someone make a choice for me. Rock? What do you expect to see?
Type.
Okay, someone else make a choice. Okay, the computer chose rock. Die chose paper. I think the player should have won. Right? Okay, remember, this is a lot complicated, man. I forget sometimes. The computer chose rock. The player chose paper. The player won, right? All right, player won. Fuck, man, there's a lot of things going on here. A lot of conditionals, guys. It's just complicated to think about. All right, so let's move on to the fun part. So now we got some data. We proved that it worked, okay? We now need to figure out how we're going to save this data. And I think the best way is to create an object and stick that object in our array, because that's the best design pattern. Trust me. You guys want to have objects. You guys want to have arrays. I don't want to work with strings all day. Nope. So we're gonna. Okay.
You said the set state you usually put at the bottom, right?
Yes, it's almost always at the bottom. It depends. There are a couple situations in which you set state first and you want something to happen, and then you want to do something else. But it depends. Okay, it just depends. For this example, we're gonna say at the bottom.
So you mean they are different? They're different case. If you put it in the top, it's gonna happen different.
Exactly. Yeah. There are many different cases. It depends on what we need to happen in what order. It depends on many different things, guys. So we're gonna create a new object, and we're gonna call this one new game result. Okay? Because this is a new game. We just played a new game. So we're gonna say result is equal to result, player choice is equal to player choice, and computer choice is equal to computer choice. Okay? So now we also need to grab one more piece of state. We want to get our game history. And then we want to do something with our game history, guys. What do we want to do with our game history? We want to push some data into it. New game result, right? Because that's the variable that we define on line 59. Okay? Then with game history, we also just want to set state to this object as well, or to this key as well. We want to update our game's history. Okay? Lastly, what we want to do is set our player choice. No. We want to set our player choice to null. Okay? We want to set it back to null. It's like resetting the game. It's saying, okay, the user needs to choose now. Okay? Does that make sense, guys? Setting the player choice back to null? Okay. If the user's choice. If the user's choice. Okay. All right, so we reset. The computer says scissors. They chose scissors. We choose scissors. And let's look at our game history. Okay, so our game history a second ago, it had 0 items in it. This array had 0 items in it. Afterwards, we see that it had exactly 1 item. And this item was an object. The object had a computer's choice, had a player's choice, and it had the result. And it made me realize that we made a mistake. When the game chooses, right? When the player chooses, we need to reset. We need to automatically generate a new computer choice. Okay? So we're gonna hop back over here. We're gonna copy this right here, this line, and we're just gonna, we're gonna paste it right here. So now we have our computer choice. Okay, no, we'll call this one new computer choice. Okay. Now we're gonna set the computer choice of the state object to be this string. Okay. Where we at, guys? Where we at? Okay, we're here. Okay. So refresh. The computer chose paper. We choose scissors. The computer did in fact choose a new choice. So now the computer has scissors. And a second ago, the computer chose paper. I chose scissors. What should we have seen? We should have seen the computer chose paper. The player chose scissors. The player won. Okay, so we're validating our program as we're building, guys. We're constantly checking to make sure that our expectations are met. Okay. All right. So okay, so that looks good. Okay, so now like this UI, like we're pretty confident that our logic is correct, right? Now we need to do something a little bit better in terms of generating UI for the user to understand what's going on. Okay, so I'm gonna cheat because I don't want to fuck this up. Okay, we're gonna jump back to Bootstrap, React Bootstrap. We'll look at our components. And we're gonna copy some. I'm just gonna copy some cards. This looks like a good idea to me. So I'm gonna say, whichever one looks good, guys. Come on, let's pick one. Come on, which one looks good? I'm just gonna get one of the first ones. Those ones are always kind of basic. Okay, let's get this one right here. We'll just copy this code. Okay. We're just going to leave our code right here that works, right there. We're gonna render this just to make sure it works. Do you guys see this red right here? VS Code is warning us card is not defined. Where did I just get card from, guys? Yes. Thank you. Thank you. I love it when you guys are paying attention. So we save it. Then we hop over here, refresh. It's the exact same card we had earlier. We took one too many cards, guys. So let's go ahead and take one. No. All right, let's just go ahead and delete one. Okay, so now let's go ahead and take our buttons and stick it in this card. Okay, this looks all right. So now our image here sucks. We need to do something here, this right here, okay? And my solution I suggest you guys do is call a function. And this function should return what goes inside of here. What should go inside of source, guys, on line 77? It should be a string, but the string can be one of 3 different strings. Okay? It can be one of 3 different strings. And we're going to figure out how to do that using a function. We're going to define a new function called getAppropriateImage. Appropriate image. And we're going to call it. We don't have this function yet, so we're just going to define it. It's not going to take any arguments. And what are we going to do here? We need to return something based on some values. I'm going to copy this because I don't want to go get links anymore. I'm sorry, guys. I'm copying. I just don't want to go get links, okay? So this isn't really that complicated to think about. We're just saying, hey, man, let's look at our state of our application. If the player choice is paper, we're going to show a piece of paper. If our player choice is rock, we're going to show rock. And obviously the same thing with scissors. And then lastly, we just chose a random image. Okay, a random image that said, hey, play the game. Okay, guys? So I'm going to save it, refresh, and we see that we do have the image. The player has no choice right now. There's no choice. Thus, this image is chosen. But if we choose paper, what do you think about this? This dot get appropriate image. This dot state dot. Player choice. This dot state dot player choice. Oh, we need to leave this right here, okay? We don't set it back to null yet. Let's try it one more time. Okay, there we go. You guys with me? So after our player chose, we didn't set our player choice. We didn't set it to null. We set it to whatever it was. Okay, so now we can use this data to create more complicated behavior. We can see that by using a function, creating a little itty bitty function and calling it, we could get a string back. Let's do something a little better. Let's get back some HTML. So we'll define a new function that will control our UI's text. We'll call this one get prompt text. Get prompt HTML. Okay? We'll fire this function. What's this function going to do? It's going to look at our state. Okay? So it's going to look at our state and it's going to return something based on the state. Okay? We're describing what's going to happen. So we're going to say if player. Okay, let's get this this dot state dot player choice is equal to scissors. We're going to return an H1 that says you chose scissors. Okay, now we'll do the same thing. Oops. Except for rock, paper. Okay, so what do we want to see a change here, guys? What was this function doing? It's giving us a prompt, and it's nested inside of some JSX. So it will give us some text, okay, guys? But notice how none of these conditions are met right now because the user hasn't done anything yet, right? So lastly, we can simply return H1, please make a choice. So I would guess, my expectation is I should see this text on the screen when we load the page. Because when we call this get prompt HTML, it's going to return something, right? It's impossible. This function cannot return not something. There are 3 conditionals inside of it. If none of those conditionals are met, the last thing it will say is please make a choice. And we see that did in fact work. Okay, guys?
Could you add the prompt with the photos?
We could, but that becomes more difficult to think about. This logic should be separate, and eventually we're going to get much better at this. Do you see these function calls that we're doing? One day these are going to be components. When we get better, these are going to be components. They're not going to be function calls only. Okay? But this makes it a lot easier to reason about. Because if we did what you said about the photos, now this conditional right here gets more complicated. Okay, just trust me. I want you guys to write a bunch of little functions, man. I think it's the best way to do it. I've spent a lot of time thinking about how to do my job better, and a lot of time thinking about how whenever I start a company, how I can be the best coder on my team. And I believe that this is the best way to do this. It's very explicit. You know what? I actually fucked up, man. This should be called render player prompts. Okay? And because get appropriate image does not in fact control the rendering of this card image, we're not going to call it that one. But we could change it to render image. So let's save it, make sure we didn't break everything. So we say rock. Okay, the image changed to a rock. Oh, we can see that our choice, does that work?
You just change the name. You just change the name of the vendors.
Please make a choice. Oh, because I made a capital R. So validations, guys. So rock. I chose rock. We saw a rock image. I chose rock. Yeah. So if I chose paper, we see paper, and the text says paper. And scissors, text says scissors. Text says scissors. Paper says scissors. Okay. We're gonna do one more. I'm gonna cheat some more, guys. I'm the laziest programmer in the world. Why is it so small? Why can't I scroll here? What the fuck? Okay, there we can scroll. Okay, list group. I want to see something basic like this, okay? I'm gonna copy this whole thing because I'm lazy. Okay, we're gonna add this over here. We'll just say it's over here. Clean it up a little bit. Okay, we check. Yes, thank you. I'm so happy you guys are, like, you guys see the error messages. You guys see the warnings from our lints, ES lints. You guys are helping me. Okay, we see some choices down here now, guys. Okay, so that looks like that worked well. Let's delete all of them now. And guess what I want us to do now? We want to look at our game history, but we want to write a function that creates our UI for us. We're going to say this.get render game history. Okay? We're going to call this. And we're just going to copy this right now. For every single game, we're just going to stick one of these inside. So we're going to say render game history, okay? And then we're going to say this dot state dot game history dot map game. And we're going to say return this right here. And we're going to say some text. We're going to say game.result. Okay, game.result. I'm keeping it simple, guys. Obviously, we can have this be more elegant. Let, what is this? Const game history HTML equals, okay? Then we're going to return game history HTML. Whatever is inside game history HTML is going to go inside this list group, okay? So let's save. Let's go ahead and click. We can see we had a tie. We had a tie. We had a computer 1. We had a paper 1. I confused myself a bit. I confused myself a bit. I'm sorry, I was moving way too fast. Okay, let's think about this. Let's go ahead and console log again. Let's go ahead and console log up here because I'm not sure everything's working correctly. I really am not sure. Okay, I just made this up on the spot. We're gonna console log our state and we're gonna reason. Okay, we're gonna go slow and look at our state. This dot state. Okay. This dot state. Okay. So we can see that when the page first loads, the computer chose scissors. Okay. So we chose scissors. I want to see a tie down here. Scissors. Ah, there is a tie. And when the page rendered again, we got a new choice by paper, or by the computer, paper. So the computer chose paper, and I want to win. I want to win. What do I choose, guys? If the computer chose paper and I want to win, what should I choose? Scissors. So if I choose scissors, I should see a win right here. Okay, guys, any questions? Any questions? All right, I want you guys to build that app.